Welcome to 2.6, everyone. We're going to go ahead and get started on some of these word problems. Here's a remark to get us going on these demand equation styles. So in economics, revenue R in dollars is defined as the amount of money received from the sale of an item and is equal to the unit selling price P in dollars of the item times the number X of units actually sold. That is, R is equal to X times P. So the number of units sold times the price is going to give you the amount of money you received from the sale, the revenue. In economics, the law of demand states that P and X are related, so as one increases, the other decreases. For instance, if the price of an item is increasing, the chances are the number of units being sold is going to decrease. The equation that relates P and X is called the demand equation. So for our problem, the price in dollars and quantity X sold of a certain product obey the demand equation. Our price is equal to negative 16X plus 100 on X between 0 and 600 inclusive. So this right here is our domain. And I may not always give you the domain, or in other cases you may not always have the domain, but when you think about this equation and what it represents, its price, the price has to be greater than or equal to 0. So you need the price to be greater than or equal to 0 for these answers, for this X values to make sense. So when you solve this, you'll subtract 100, and then multiply both sides by negative 6, and you're going to end up switching the inequality here. And so X is less than or equal to 600. Notice that's not the same as what's given here, so we still have to pause and think about this as, well, wait a second, X is the number of units, actually, the number is the quantity of something being sold, so it doesn't make sense for the quantity to be negative, and so that's why we had to state that X is greater than or equal to 0, but less than or equal to 600. Okay, so for part A, we want to find the revenue as a function of X. So go back to your equation here. We know R equals X times P. And in part A, it's wanting us to do R as a function of X. We want it to be R of X equaling X times P. But this part is the funky part. We want it to be in terms of X. And so having P here is not good. But we know P is negative 16X plus 100. And so I'm going to replace that with it. Now I have R as a function of X. I'll distribute X. And here is my revenue. And just some things to notice when we look through the rest of these parts. We want to, for part B, we want to know what is the revenue if 200 units are sold, what quantity X maximizes the revenue, what is the maximum revenue, and what price should the company charge to maximize revenue. Before I just delete all this, I wanted to talk about just the function that we have. So just some of the properties that we can see is that the parabola is going to be reflected over the x-axis. And so when it's reflected over that x-axis, it's going to have that maximum, it's going to have a maximum value. In that case, it makes sense when we see maximum revenue, or not, the maximum revenue, this is our Y value here. And so we're happy that we're seeing the negative there, because then when we look at the rest of these parts, we know that we're on the right track. Alright, I think I can put in part B right here. So we want to know what is the revenue if 200 units are sold. And the units sold is represented by X. So right now we know X is 200. So that really means we're trying to find R of 200. So you're plugging it in. And well, we're gonna definitely start by squaring this first, timesing it by -1/6, do 100 times 200. We're gonna eventually get to -2. Oh, there's just a lot of zeros. Let me just write my answer. It's gonna end up being 1330. Oh, that's delay. We should end up getting this. So definitely just make sure you hit pause for a quick sec to crunch the numbers to confirm you get this for your revenue. Alright, let's go ahead and look at part C and D. I'm going to erase this. And I just want to write my revenue equation up here. Okay, and so for part C, what quantity X maximizes the revenue? What is the maximum revenue? So again, visually, we're thinking of the parabola is doing something like this. This is just a definite sketch, but what we want to know is what is this X value that causes this peak, and then this peak is the maximum revenue. And so this is using, I think it's 2.3 where we find, or maybe it's 2.4 where we find the maximum revenue. And so at this point you have to realize, where does the max occur on a parabola? The max occurs at the vertex. And you have some options on how to find the vertex of a parabola, but I would go with finding X equals -b over 2a, and then R of -b over 2a. I guess I didn't really need the X there, but it's kind of a force of habit. So you're gonna plug in, you're gonna use the A's and B's from your revenue equation, plug it in to find the X, which is this part, and then find R of that value you just found to find the maximum revenue. So let's go ahead and do that. X equals -b over 2a, which is going to be negative, and then b is 100, over 2 times -1/6. The negatives cancel. 2 over 6 is 1/3, so then that means 100 divided by 1/3 is 300. So the quantity number of quantities needed to reach the maximum revenue is 300. And now we'll find R of 300 which is going to equal -1/6 300 squared plus 100 times 300. God, I'm having bad luck with this pen today. And when you crunch these numbers, you're going to get not negative, 15,000. Oh. So one thing to keep in mind is when you're asked to find the max, make sure you're paying attention to the details. By definition, the maximum value is the y value. In this case, I'm asking for where does the maximum occur and what is the maximum value. So this is where the maximum occurs. It occurs when x is 300 and the maximum value is 15,000. Alright, so before I delete this, we want to make sure we look at part D first. So we want to know what price should the company charge to maximize revenue. And so it's confusing because you have the revenue equation and we kind of forgot about the price. We just found X and revenue, blah. So the thing to look at is when we look at part D is it's asking for the price. And so if you pause and go, okay, this is my price. That's the equation for my price to determine how much I should sell the thing that I'm selling. And so if we're looking for the price that can create the maximum revenue, well, we need to know how many quantities we need to sell to attain that maximum revenue. So the maximum revenue is attained at 15,000. We need to sell 300 of the product, 300 quantities of the product. And so for part D, we're going to plug in 300 for X to find the price. So from part C, we found X equals $300 will tell you at where the maximum revenue is going to occur. We're looking for the price, so we want to find P equals -1/6 times 300 plus 100. Holy cow, this pen is annoying. Alright, and so when we crunch the numbers, 300 divided by 6 is going to give us 50. -50 plus 100 is going to give us a price of $50. So whatever product we're going to be designing or selling, we want to charge $50. Alright, took a while. I'll see you in problem 2.